Notice I said most.
You didn't.
No.
Alright, so as 2-5 postulates, we're starting our 2B unit. So Miss Sartor's coming around with that. I like to have mine glued in first. So I'm going to glue mine in. We are going to write a definition off to the side here. So once you glue yours in, or if you're waiting to glue yours in, try and leave a little space there.
Glue off what side?
I'm going to write it on this side. Share those glue sticks. Please do not ruin my glue sticks. Please, please, please.
I'll drop it on the floor right there.
Just some people are trying to see how far out it comes, and it just won't go back in then, and then it just ruins it. And that's just a lot of glue to ruin. So, and when I say people are doing that, I mean freshmen. Freshmen are doing that.
Are stupid.
Wow. Yeah. Okay, freshmen are not stupid. No. Sometimes they just like to experiment with things that they should.
Well, maybe they should think better.
Okay. Actually, that's part of the thing, is that their brains aren't developed yet, so that's why they can't think through, is that their logic part. Yours is also not, but it's more developed than 9th graders. Alright, so postulates. I'm going to write the definition of a postulate off to that side.
So just like our warm-up, when we said we just know it's blue. Someone somewhere told us it was blue, and now we just know that blue is blue. A postulate is something we just know is true.
So I'm going to turn my book sideways so you can read what I'm writing. Okay? So a postulate is things we know are true, but can't prove. It is just the way it is. Sometimes math is just math. Very rarely will I say math is unexplainable. These are things that we can't really explain further. We can show it lots of different ways, but we can't really explain why this is the way it works. Okay, and again, you're going to need a highlighter and a colored pencil. I'm going to use a orange highlighter today and a green colored pencil. If you'd like to use the same, that's fine. You might want them to be 2 different colors. I don't think it really matters if they're the same color, actually. Last class, I made everyone take different colors out, but. So things we know are true but can't prove. We're going to come back to that quite a few times. So I'm going to highlight that and highlight that word postulate so I know that that's a definition. Because in case on your test at the end of this chapter, if your test asks you what's a postulate, you might want to know what that definition is.
Why do you write it sideways?
I don't know, because then it would only be like 1 word per thing. Fine. Okay, you write really small. I don't know, man.
Do it. Do that face.
No.
Make sure you're on top.
Alright, so with our postulates are numbered, and when you do your practice today, it's going to ask you which postulate says this, and you're going to name it with a certain number. Now, these numbers are not universal. They're not for all geometry everywhere. We're just numbering them so that them in class, we don't have to restate that whole thing. Technically, our textbook calls this postulate 2-1 because they introduced it in chapter 2. If we had a geometry book that introduced it in chapter 3, it'd be called 3-1. They're just numbered so that way we can talk about them easier. If you're going to study geometry, you would talk about this probably, you would actually write the whole thing out. Okay? Alright, so for our first postulate, we have through any 2 points, there is a line. Through any 2 points, there's exactly 1 line. Alright, so what's some of the key words in that one? Exactly how many?
1.
Exactly 1. So we're going to highlight that. Exactly 1 line. Okay, there's exactly 1 line. So in this part here, in this postulate, we're starting with 2 points. And then, Gabby, will you put 2 points on that board behind you? 1 point, 2 points.
Good
All right.
job.
If I was going to connect those points with a straight line, how many straight lines can connect those points?
1.
Just one. Try drawing it. Doesn't have to be exact. Give you a ruler. That's pretty straight. That was impressive. All right. There's just one straight line. If I'm connecting a point to another point, so if I'm connecting from me to Olivia, how many strings could I have attached to us?
1.
Just one. That would go straight from me to her. Okay? I like to think of this as like a dot to dot. I really like dot to dot problems. We're starting with those dots, and when we create a problem, if I'm making a heart, it has to go from dot to dot to dot to dot. That person that makes a dot to dot is expecting us to just draw one line between those dots. You don't have to draw that heart if it's too difficult for you. Or draw the heart first and put the dots. I don't know. Okay, but when we connect them, we're connecting from 1 to 2, 2 to 3, to 4, to 5, to 6. Okay, and it's expecting you that you'll only have one line to draw in between each of those points. So it's like a dot to dot. If we have 2 points, there's exactly one line we can draw.
Whoa.
We're actually going to jump down to postulate 3. We're going to skip postulate 2 for a second. Postulate 3 is really similar. So skip number 2 for a second. Postulate 3 says a line contains at least 2 points. A line contains at least 2 points.
At least 3.
Okay, at least 2 points.
3 lines.
And it contains. What does contains mean? Has. A line contains at least 2 points. How is that different than postulate 1? Through any 2 points, there's exactly one line. Looking at those pictures might give you a little bit more of a hint. But how are these two different?
So look at the picture for 1.
It only has 2 points.
It starts with 2 points, and then what?
And then goes to a line. And how about 3? What do we start with in 3?
Just a line to 2 points.
And then we have
So with this one, we're starting with a line. And then based on that line, we can do 2 or more points. It's at least 2. Because a line has to kind of have like a starting point, and if it's not connecting anything, then it's just a point. A line has to have that length to it. So it has to have at least 2 points. Okay, so this one you're starting with a line, and then we're doing the points. Where postulate 1 starts with the points and then line. Okay, so they were very similar, they're just kind of flopped. Does anyone remember what we call that thing when we flop something? Switch place it. Close, not inverse, that's opposite. Converse. It's almost like a converse. We're starting with the opposite thing. Here we're starting with dots, then we're going to the line. Here we're starting with the line, we're going to dots. Alright, let's go back to number 2.
I made an oopsie.
Oopsie. Number 2, through any 3 non-collinear points, there is exactly one plane. Through any 3 non-collinear points, there is exactly one plane.
So what are some of the big words you see there? Exactly 1. Any 3.
Through any 3 non-collinear.
So let's look at that word non-collinear.
What prefix do you see in non-collinear? Non. So non means not. But then there's another prefix.
Close.
Go. Sorry, Miss Sarda, this is your
And
thing.
then we also have your that word line. And what does co mean? What cooperation with them? Together.
Together. So non means not together on a line. So we have 3 points not on the same line. All right, we're going to try this again in this class. We'll see how it goes. All right. All right, Destiny and Abdirman. You guys gonna put up? You're gonna put up one finger. You're gonna put up 2 fingers. Okay, so you gotta be closer to her because I gotta use this. Okay, a little bit closer. There you go. All right, right now, are those 3 fingers in a line? No. Can I put the whiteboard on it, the plane? Can I put it on it where it's touching all the fingers? Okay. What if Abdirman's was way up here? Could I put that now?
Okay. Yeah.
Yeah. It has to be a little bit longer. Yeah. What if Destiny puts this one here? That one's up like that. Can I put it where it's like that, where they're all 3 at different levels?
Yeah.
Yeah. It just has to tilt differently. But because we have a flat surface, we have that tilt. So it doesn't matter where those 3 fingers were, where those 3 points were. We can tilt so that it works. All right, so I'm going to put that in there too. If that's something that doesn't help you, for me that word tilt really helps. Tilt. To touch all 3 points. Okay. Sí. Es mismo dos. Sí. Este. Sí. Espera. El otro. Sí. Sí. Luego el siguiente. No sé. All right, number 3 and number 4, again, I'm sorry, let me say that again. Number 2 and number 4 are really similar. They're kind of like those converses again. We're kind of switching it around. So number 4 says a plane contains at least 3 non-collinear points. So what are some of those key words again? Non-collinear. Non-collinear. And a plane has at least 3 points. So that's our conclusion, is that if I start with a plane, we can create 3 points. Okay? Cody, can you stand up and put 3 points on that plane that are non-collinear? So plane is the whiteboard, that flat surface. Cody is going to put 3 non-collinear points. 1, 2, 3. Did they fit? Yep. Eloise, we put 3 non-collinear points on that plane. Beautiful. Eloise put 3 non-collinear points on this plane. If I move this plane like this, are those 3 points still on it? What if I do this? Yep. What if I rip off one of those points? Could I have drawn now? Is there still 3 points on there that are secretly hiding?
Could there be 3?
Could there be 3? You had 1 more point on there? Beautiful. Yeah, we can keep adding points. If I rip off another one, now there's 2, but really we could add a third. Add a 3rd point. Should we keep doing this? Is this fun? Forever and ever and ever? Magic. All right. So, doesn't matter how that plane is tilted, if it's up high, if it's down low, if it's side to side, up and down. That plane is always going to have 3 points, non-collinear. Okay? So, this is like different sized papers. No matter the size of the paper, we can always get at least 3 points. Actually, we already used the word at least, so let's say 3 or more. If you already put at least, that's fine. But we can do 3 or more points. Now, if you wanted to be a smarty smart person, and you want to try and prove me wrong, you would maybe ask, okay, but what about this? And you get 3 points on this teeny tiny little piece of paper. Would you? Yeah. What about this teeny tiny piece of paper? Little one. I can't even show it to you because it's so small. Yeah, we would need a teeny tiny little pen. But could you at least find 3 different parts to it? Even if we didn't put a pen on it, the actual points, could you find 3 different pieces to it? Yeah, you could look at it in 3 different spots. Okay, so it doesn't matter that size, we're always going to have 3 or more points. So again, what's the difference between number 2 and number 3? I'm sorry, gosh. Number 2 and number 4.
The first one starts with points and leads to the plane. Number 4 starts with points and looks for the, or starts with plane and looks for the plane. Oh my goodness.
It's struggling. All right, number 5. If 2 points, this one's really not that complicated, I promise. If 2 points lie in a plane, then the entire line containing those points lies in that plane.
So start by looking at that picture. And then let's go back to the words. What are we actually saying here? If 2 points lie in a plane, then the entire line containing those points lies in that plane. What are some of the big words? Or the big ideas here?
Okay, 2 points. And what are those 2 points doing? They're lying in a plane. They're just having a nap. Lying around. Then what? That entire line containing those points also lies in that plane.
Because remember, what postulate 1 says? If we have 2 points, we can make a line, right? The really important part here is that line. Learned about lines intersecting planes and things like that.
Okay, Cody has these points drawn over here. I'm going to just reuse them. If I draw a line that has those points on it, could I put that line out here in front of it? Does my arm have those points on it? No. In order to get points on my arm, where does my arm have to be? On the points, which is on the plane. It's kind of like it's all together. Okay? Through that plane, because if it goes through that plane, it only hits at that 1 point. So, the big thing here is that we are going to list what it can't be. Okay? It can't be above. It can't be below. So that line can't be above, it can't be below, and it can't be through. Which when we say through, we're looking at that word intersect. So that line can't be above the plane, it can't be below the plane, it can't be through the plane, it has to be on the plane. Or in the plane. If you want to use the word in or on, in both cases would be. All right, the next two are similar. They're going to talk about intersecting. Remember, what does intersect mean again? Crosses. This first one, it says if 2 lines intersect, then their intersection is exactly 1 point. So what's important about this one? What are some key words? Yep, we're doing 2 lines, and what are the 2 lines doing? intersecting. So I'm going to put that in green. So two lines intersect. Then their intersection, that place where they cross, is exact. This one's pretty easy for us to understand. If you take two pencils or your pencil and your highlighter and you cross them. I don't want to do it with me. Thanks, Patty. There you go. Thanks, Gabby. All right, if you cross your marker and your pencil, or pencil and a pencil, doesn't matter how they cross, but if they're crossing, how many places are they actually touching? Just one. If they're touching the whole way across, remember that's really just one line. They get absorbed into each other. There's no depth. So when they're crossing, they're touching only in one spot. Okay? So I'm going to write that. I like the word touch because I like to think about this as physical things. So they touch, if you want to say cross, you could, but they touch in one place. And only one place. All right, now this one says if two planes intersect, then their intersection is a line. Did you want to write this one? Or do you want to do it? Demo? Yeah, I want to do the magic. I'm good at magic.
Magic.
Okay, so if two planes intersect, so let's think about some intersecting planes in this class. Where are two planes that touch?
The wall.
The wall.
And let's do a wall and the ceiling. Is that okay? As you look at the ceiling and the wall, where they touch, how many places does the ceiling touch the wall? Only once? Everywhere. It touches right here, and then it touches there. It touches here, right? How many places does that ceiling connect with the wall? Yeah, along that whole edge, right? So that whole edge, what kind of geometrical figure is that edge? Is that a point, a line, or a plane? You think about that part where it touches. Be a line, yeah. Okay, if you look at this lovely, lovely plane, see this plane? Ready, guys, for my magic trick today? Really good. Okay, here's a plane. If we have another plane, and they intersect each other, ready?
Oh, that's one smooth, not
Crazy. When they intersect, how many places are they touching in that middle part?
What?
Yeah, they're touching here, and they're also touching here. They're touching here. So from two planes, I created a line.
So if
Magic.
two planes
Thank you.
intersect,
Thank you.
then that place where they intersect, the whole thing will form a line.
Is that like 40 seconds to finish that up?
So all the points where they touch will make a line.
Because they touch in more than one place. They touch all along the line.
Did you say that?
All right, for your practice today, when you come back from lunch, we're going to be doing a whole group practice, which means everyone needs to be here. So it's very important that you are back from lunch on time.
Right by you.
Okay? So come back to lunch on time so that we can do our whole group practice together when you come back.
I have to go to